Okay, so we are going to start with factoring. I know that's where a lot of you struggle, so I wanted to spend time, that area for quite a bit. So most of the class will, or class, but most of this session will be for factoring. We'll hopefully get to solving by factoring, but I don't know, we'll play it by ear. That's why I said aside 2 days for this. Tomorrow's will not be factoring. I'll keep adding in other things like the graphs and how they look and things like that. But we're going to start with the different ways to factor. The first main way to factor is just by GCF, or greatest common factor. This is something that y'all do, and it's really not as big of a deal because I feel like I've seen you do this with enough accomplishment that I'm not extremely worried about it. But it should be the first thing you always look for, no matter what method you can use. So if I gave you 5x squared plus 10x minus 25, you need to take the 5 out of everything before you even try to do the actual trinomial. And I made this up, so I don't even know if it works. But so you'd have to take 5 out, x squared plus 2x, and then minus 5. Before you can even attempt to do anything with a trinomial, which is actually, if you look at that one, that one's not factorable. So that would be where you stop. We've done that the past couple days in the examples that we've done. So I'm not extremely worried about it, but does anybody have a question about greatest common factor? Okay. So I'm not going to touch on that anymore unless it's just integrated into a problem I find that I want to do. I do next want to do a 4-part box. Okay, I told you you may have learned in your previous class to do like grouping, and that's fine if you want to do it that method. I'm not stopping you. This is just the method that works best for me. Okay, if it doesn't work well for you, don't use it. I'm not making you use the method that I use. So first example of that would be 25x cubed plus 15x squared plus 10x plus 6. I think one of the biggest things y'all struggle with factoring is to know when to use what. 4-part box, luckily, is like the really easy one. You just see 4 parts. So today I was trying to factor something. I'm human too. I make mistakes, or I sit there and try to figure out it. I was going, how the crap would I factor this? And then about 5 minutes later, I look back down at it. And I go, oh, it's 4 parts. I'm an idiot. So always look at it and see how many parts is it. If it's 4 parts, do 4-part box, or try to do 4-part box. If it's 3 parts, you're going to have to use your trinomial methods, or you may have to go to something like quadratic formula or something. If it's 2, then you may be able to expand it into a trinomial to where you can use that same method, or it may be something where you have to do like sum and difference of cubes. So you just kind of have to look at it and determine which is best. So look at it always and say, can I take anything out? I have 25, 15, 10, and 6. If the 6 had been a 5, I could have taken the 5 out. If the 15 had been, well, 15 or the 25 had been even, I could have taken 2 out at least. But I can't take anything out of this, so I'm going to leave it alone. And I'm going to draw my 4-part box. Each part goes in the box. And I told you before, normally, unless they just write it really weird, which they shouldn't, but if it's in standard form, meaning cubed, squared, x, then an actual number, then it just goes in order. 25x cubed, 15x squared, then 10x, then 6. You technically, to make sure that it would work, you multiply the diagonals and make sure they're the same thing. So 25x cubed times 6, and then 10x times 15x squared. If they equal the same thing, you can do it. If they don't, you can't. So keep keep that in mind. It may be useful. So then you're going to look at going straight across. I do rows first, but it doesn't matter which one you start with. So the first row, we have 25x cubed and then 15x squared. 25 and 15, what can I take out? Somebody else speak up, because I basically said it. 5. X cubed and x squared. X squared, right? Make sure you always take that lowest exponent, because that's the most I can take out of it. I can't take more than x squared out of that second one. So 5x squared can come out of both. So you're doing the same thing as your GCF, you're just doing it in little parts now. 10x and 6, what can I take out? 2. Remember, it's always the sign of that first box. So my first box here was positive, so this is positive. My first box here is positive, so this is positive. Now we have 25x cubed, and we have 10x. What can I take out? 5x. Very good. We have 15x squared and 6. 3. Okay, everything's positive, so we have 5x squared plus 2 times 5x plus 3. It doesn't matter which order you write it in, you could reverse them. Any questions there? If there's a squared, I normally would look at it and say, okay, can I do anything else with it? If you can take the square root of both parts and it has a minus, that's the only time you'll be able to do anything else with it. This one doesn't meet either of those requirements. It's a positive, plus I can't take the square root of 5 or 2, so not evenly. So I'm done, and this is as far as it can factor. Any questions about 4-part box? If I said, hey, I want you to solve this, not just factor, but I want you to solve it. And I could have been very specific and said, I want you to solve by factoring. So I need to see the factoring and I need to actually see the solution. You would take both of these parts and you would set them to 0 and solve. Same concept as kind of we talked about in class today with what was in the denominator. Right? To actually solve for that x, we had to set it equal to 0. So we have 5x squared plus 2 equals 0. What's the first thing we do? Yeah, you're going to subtract 2. Then what? How do you get rid of 5? You divide. So, divided by 5, x squared equals negative 2/5. Okay, how do you undo square? Yep, square root. So, I have x equals the square root. When I take the square root, don't forget plus or minus, right? I just told you up here it's x squared, so it's 2 x's. I have to show I have 2 solutions.
Andrea Johnson, if they're in the building, pick up a beige phone in the classroom and call 602 Andrea Johnson.
My beige phone. Okay. Yes. So we take the square root of negative 2/5. Now, I would just keep the square root of 2/5. But anytime you take the square root of a negative, it's an imaginary number. So you're going to put an I outside. Okay. We vaguely touched on that. We didn't touch on it as much as I had wanted to. It's really not that hard a concept. Square root of negative 1 is an imaginary number. It's an I. So anytime you have a negative, you pull it outside and make it an I. Any questions about that? Okay, so you would have to look and see, like if this was a multiple choice test, obviously, you would have to look and see what kind of options they have. They probably wouldn't have the square root of 2/5, they would probably have either the decimal or they would have broken it down if they could, which they can't. So I would assume they'd have a decimal. So x equals plus or minus the decimal number and then an I beside it is what it would have looked like. I don't know what the decimal of square root 2 is. Sorry. It's not in my knowledge. Okay, and then 5x plus 3, a lot easier. I would just divide by 5, or subtract 3, then divide by 5. So my answer would be plus or minus I square root 2/5, and then x equals negative 3/5. Is there any questions about that? Okay, so you always have to see what they want. If you can factor a 4-part box, if that's not hard for you, then hopefully you should be able to also solve by setting it to 0. I know that this was on your released items. I think it was number 2 that you could use this concept for. Go back and double check at some point. And we'll talk about it tomorrow too. Any more time? Very good. Okay. Make sure. Okay, so that's 4-part box. Now we're going to go to trinomials. With A being 1. Okay, so if we have a trinomial with A of 1, what I mean by A is you have that standard form, ax squared plus bx plus c. And so what I mean is in front of x squared, you would have an invisible 1 or a written 1. Usually it would not be wrote though. So let's do x squared plus 3x minus 10. Okay, it's really not that bad. All you do is you look at this last number and you say, what's 2 numbers that multiply to get negative 10? But add to 3. Okay, it's always multiplies to the last, adds to the middle. Okay, so my suggestion is if you struggle with it, which some of you do, start just listening to multiples of negative 10. What do we know about the signs if it multiplies to get a negative? It must be opposite. If it's the same, even if it's negative or negative, it multiplies to a positive, which is not what we're looking for. So because it multiplies to a negative, we have opposite signs. I'm going to go ahead and make a note there. Well, 10 only has 2 options. It's either 5 and 2 or 10 and 1. But I would also add 2 more options by flipping my signs again. So 5 and negative 2 and 10 and negative 1. So that lists all my options for multiples of negative 10. Which one adds to positive 3? 5 and negative 2. As soon as you know those numbers, you just say x plus 5 times x minus 2. questions there? Okay, if I told you to factor, you're done. If I told you to solve, then it needs to be x equals -5 and x equals +2. Any questions? Okay. Number 2. X to the 4th minus 4x squared minus 5. It looks different because you have to the power 4 and to the power 2, where you're used to a power 2 and a power 1. It's not going to work any differently. The only difference is here you had an x and an x. There it will start with an x squared and then an x squared. Okay? The only way that you can do trinomials in this method is if this middle one is half the exponent of that. So I could have 8 and 4, I could have 16 and 8, so you're not ever going to have halves or anything. So you're not going to have an odd number than some crazy one, but you get the idea. So I think to the power 4 is the highest you should expect to see. You create your two parentheses, and instead of x to the 4th, you're going to put, or instead of x, you're going to put x squared. Think about it. If I multiply this out with full or distribution, however you want to do it, x squared times x squared is x to the 4th. Okay? And when it created that first and that inner, or no, the outer and that inner part, it would be like an x squared plus an x squared, which would give you this middle part. So that kind of makes sense. Okay? Same concept. I still need two numbers that multiply to my last but add to my middle. Can anybody think two numbers that multiply to get -5 but add to -4?
+1, -5.
Right. -5, +1. If I asked you to factor, you have to make sure you factor it all the way. I told you that if you have something like x squared minus a number, check and see if you can take the square root of it. If you can do difference of squares. I can't take the square root of 5, so that's not going to happen. Now, if that was a 4, I could have broken it down more. If I asked you to solve, though, you need to set both of them to 0. On x squared minus 5 equals 0, I would add 5. And then I would take the square roots of both sides. Don't forget, because I know it's a common thing, don't forget square root, you do plus or minus. And 5 is not a perfect number, so we just leave the square root of 5. So I have a positive square root of 5, I have a negative square root of 5. Any questions about that part before I move to the next one to solve? Okay. X squared plus 1 equals 0. I want to subtract 1. And I'm going to take the square root. And this is kind of the perfect example for an imaginary number, because I told you as soon as you see a negative inside, it becomes an I. What's the square root of just 1? Yeah, it's just 1, right? 1 times 1 is 1. So it's just x equals plus or minus I. I, by definition, is the square root of -1. So any questions? This would be a good point for me to also make. It's kind of like a side note. It's not really factoring, but you need to know it. If I told you that I have a 0 or an x-intercept of 5 minus I, and I said, okay, that's great, but what's my other x-intercept that I know I have? If you have 5 minus I, you also have 5 plus I. Okay? It's called the conjugate of it. So they always come in pairs. So I have a positive I, so I also have a negative I. Any questions about that? Everybody still need this paper? Okay, everybody's yelling at me. That's awesome. Okay, now we're going to go to trinomials when A is not 1, and that one's not as easy a process. I taught you how to kind of integrate 4-part box with what we call the AC method. If that method does not work for you, let me know and we'll try something else. But you will have to know some way to do it. I mean, luckily, sometimes with multiple choice, if you really just wanted to do it for test prep, which you probably shouldn't, you should actually care about learning. You could always multiply it back out. Like if it gave you an answer, you can multiply it back out to check your work on the answer choices. But so this is trinomials. If A does not equal 1, so we're going to do 3x squared minus 5x plus 2. I'll give you a pretty easy one at the beginning. Okay. The AC method that I told you was, first of all, you have to say A is 3, B is negative 5, C is 2. Okay, which is something that I'm sure y'all are all okay with. But if you're not, just ask questions. The next thing you would do is say, okay, what is A times C? And this one's 6. You did that when trinomial was 1, but you had a 1 here, and so it went 1 times that number, and it just happened to be that number. So you really did this method with that. We just didn't say we was doing it. Okay, so A times C is 6. Now you're going to find your multiples of 6 that add to negative 5. So you're still doing that concept of 2 numbers that multiply to the end to add to the middle, but we had to include the beginning too in it. So multiply to equal AC, they add to equal B. That's always going to be your rule for this. We've already talked about when it multiplies to get a positive, they both have to be the same sign. If it adds to a negative, those signs have to be negative. If they were both positive, it would add to a positive. So two negative numbers that multiply to get 6, but add to get negative 5, what are they? Okay, so we try. You said positive 1 and negative 6, but what's 1 times negative 6? Right, and I need a positive. So that's why we go back to the negative. Because negative times negative will be a positive. 3 and 2. Negative 3 times -2. And always double check it. Sometimes if you write it down, it kind of helps you see it a little better. Okay, so -3 times -2 is +6. -3 plus -2, oh, that is -5. So that's my right option. You have other options that may work for one but not the other, such as this. That helps if you always sit there and go, okay, this is what I have. Now, does it make sense for both? Okay, we do this to rewrite our middle terms. Okay, -3 minus 2 is -5. So I'm just rewriting it. I'm not changing who it is. I'm just giving a little bit of cosmetic surgery to where I can adapt it better with the 4-part box. So now I have 3x squared. I'm going to use minus 3x minus 2x. Then my plus 2 doesn't end. So the only thing that changes is my middle. I'm just expanding it out. Is there any questions about that? I do that because now I can do my 4-part box, which would help me factor. So I have 3x squared minus 3x minus 2x and 2. Is there any questions about putting it into the box or anything so far? Okay, take out your GCF. What can we take out of 3x squared and 3x? Yeah, 3x. And we'll deal with our signs at the end. So negative 2x and 2. Okay, so we're going to pull out a 2. Why is it negative? Right, it's always that first box. 3x squared and 2x. Yeah, I can only take an x out. And then negative 3x and 2. If you can't take anything out, what can you always take out? Yeah, 1, and it's negative because of that box. So I have 3x minus 2 times an x minus 1. If you only had a factor, you would be done. Yet again, if you had a solve, you would set both parts to 0. If I could write. So add 2 and divide by 3. So 2/3 and positive 1. Depending on what the question was, obviously. Is there any questions about that? Okay, I'm going to do one more where A is not 1. I'm going to do one that has a higher number in it, just so you can kind of see where sometimes you have to play with the numbers, because those are pretty low numbers, especially for trinomials with it being 1. It's still going to start with a 3 though, so 3x squared plus 31x, then plus 56. You always want to look at it, especially when you start getting really high numbers, and go, can I take anything out? Well, 3, 31, 56 is not going to happen, but it was worth at least looking at. Because there's been times that you have had really giant numbers, and it's been cut drastically by just taking out something. So, A is 3, B is 31, and C is 56. Okay, you still go A times C. The process doesn't change just because the numbers went up. It's 168. 56 times 3 is 168. So you have to find two numbers that multiply to get 168 and add to 31. It's not numbers that you're going to know off the top of your head. I know that. You sit there and play, so I would look at it and go, well, I know it's even, but even if it's divided by 2, it's going to be a really big gap, much bigger than 31. So that's not going to work. I do know because it multiplies to get a positive and add gives a positive, that it's two numbers added together, right? Two positive numbers added together. So that helps. You can start with going like divided by 4, which would be 4 and 42, but that's still going to give me a 46 if I add them. So right now I have 4 and 42, which is 46 if I added them. So I know that's not going to work, still too high. Then I say, okay, well, if it's divided by 4, maybe it's also divided by 8. Okay, so 8 and 21. It's 29. Okay, so 8 was too much. I needed to try something lower. We know it's between 4 and 8. I'm just now going to start going down by 1 each time. So 168 divided by 7 is 7 and 24. Well, 7 plus 24 is 31. Okay. I really didn't have to do a lot of thinking. I really just sat there and kind of played with it for a minute and said, okay, well, I'm going to narrow down my options until it finally adds up. So 7 and 24 are my new middle terms. So I have 3x squared plus 7x plus 24x plus 56. Yet again, the only thing I rewrote was my middle terms. Any questions about that? And then do your 4-part box, which I'm going to go through quicker just because of time. Okay, so you would have, you can't put anything out of here except for an x. That's right, okay. An 8. Here I could pull 3x out, and here I could pull a 7 out. So I have x plus 8 times 3x plus 7. I'm not saying it's the easiest thing to do. It's more tedious than anything, though. It just takes a little bit of time. So if you're patient enough with it, it's not that bad if you can just work through enough of them. Sometimes with these, it really is one of those practice makes perfect. Y'all know that I'm not one of those people that's going to give you 50 problems to do, but this is one of those concepts that it benefits to have 50 problems. So if any of you want extra problems to kind of work through on those to practice, that's fine. Let me know. It doesn't take me long to make them up. So.
Tom Stone, if you're in the building, please call 602.
Any questions? Does anybody need another example of those, or do we feel okay with them? I'm fine either way. Okay. So that's your main factoring ways. You have one more way that's like a special factoring method. It is only for very certain cases. It is sum and difference of cubes. So sum and difference of cubes require it to be something that is cubed. So we have the rule is a cubed plus b cubed equals, and it gives you a format to follow. A plus b times a squared minus ab plus b squared. Okay. You have to remember it. There's no other way around it. If you remember the positive one, though, the negative one's not bad at all. It's just a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Knowing both forms would just make it where you don't have to worry about the signs. If you can only remember the positive one, if you plug in negative numbers where it's supposed to be a negative, then you're fine too. So whichever method you would prefer to do, that's fine. Okay, so if I have 1 be 125 x cubed plus 8. The rule is I can only have two parts, which I do, two terms, and both of them have to be able to be raised to the power of 3 if I change them. So I have to be able to take the cube root, basically. 125 in the terms of to the power of 3 is 5 cubed. So this is basically saying 5 to the power of 3 times x to the power of 3 plus 8 is 2 to the power of 3. So the thing is, everything in there has to be able to written in form of to the power of 3 even. If that 125 was even a 124, even off by one number, it doesn't have a perfect cube root, so you cannot do the method. You cannot factor it. Okay. So the idea is that if this is a, so if a equals 125 x cubed, sorry, a cubed equals that. What is a? Well, we already said that 5 and x are the things that are cubed, so it's just 5x. B cubed equals a. Well, what is to the power of 3 is equal to 8? Well, that's 2, as we just said. I figure you know 8 and you know a couple of other basic ones. You may even know 125. If it's one you're worried about and you're not really sure if it's a cubed root, if you'll just go onto your calculator and hit, where is it? Math, and then go to option 4. It does cubed root, so do cubed root of 125, and that gives you 5. Okay. So we have a is 5x and b is 2. As soon as you know that, you can plug it into your format, because our format says a plus b times a squared minus ab plus b squared. So plug in 5x plus 2 times 5x squared. What's 5 squared? 25. And x squared is just x squared. So you have to square both things. And that's one of the mistakes that I usually see is you just square the x, but you don't square the number. Minus 5x times 2, which is 10x. And then 2 squared, which is 4. Any questions about that? Does anybody need me to go over anything else about how to get there? I will tell you, 5x plus 2, obviously you can't factor. Normally you would look at that last one and say, oh, it's a trinomial, I need to try to factor it, which right now you're probably saying, please don't, because those are big numbers. But you don't have to worry about it, because in a cubed root, when you use that format, that second one is always unfactorable. It cannot be factored correctly. So you'd have to use some other method if I said solve. You could do 5x plus 2 set to 0 to solve it, but 25x squared minus 10x plus 4, you would have to use something like quadratic formula. Would probably be your best bet. You could do completed square, but quadratic formula would probably be easier option, which we're about to go over that. So we'll probably continue with this problem just so we can solve it with quadratic formula. Okay. I'm going to leave cubes alone unless somebody just needs me to do another one. Is there another example somebody needs? Okay. So we're going to solve this one because we need to practice quadratic formula. So I'm just going to kind of write down quadratic formula real quick. Okay, remember it's negative b plus or minus the square root of b squared minus 4ac is all over 2a. Okay, you're still going to use the same a, b, and c that you used when we did like the trinomial method. So that doesn't change. So for this example, whenever I'm factoring, or not factoring, but solving with quadratic formula for this one, so I have 25x squared. Let me switch to another piece of paper so I have room. So I have 25x squared minus 10x plus 4. And I'm going to use quadratic formula. A is 25, B is negative 10, C is positive 4. You start plugging these numbers in. So I'm going to go ahead and write my formula down. Negative 10 is a positive 10 plus or minus the square root. Negative 10 squared. Now, one issue with that, as soon as y'all type that in, you tend not to put parentheses around it. It's going to be squared, so it's going to be positive anyway. So as soon as you put it there, if you want to write just a positive 10 squared, that's fine, to prevent from you making a mistake. Minus 4 times 25 times 4 again. And then over 2 times 25. When you're solving these, the first thing I told you to type in, I said don't type in the square root and do not type in this whole thing. The only thing you type in is what's underneath the square root. So you have to solve for underneath. It's called our discriminant. Okay, solve for the discriminant first. So just write down the other stuff that you had. And 2 times 25 is just 50, so I'm going to write it down. And in your calculator, you're going to say 10 squared minus 4 times 25 times 4. And I get negative 300. Questions about what I did? Okay. When I said there's a negative inside of a square root, what do we do? What did you say, Tabitha? It's I. So 10 plus or minus I square root of 300 over 50. That's why it wasn't factorable, because it was imaginary numbers. It wasn't a real solution. Okay. Now, we're not done. You need to break this down as best you can. That 300 can be reduced. Okay. So that's when you go off to the side. And you say two numbers that multiply to get 300. Well, 30 and 10 work for me. You could have done 3 and 100. It doesn't matter. Then 30. 3 and 10. I could technically keep going and go 5, 2, 5, 2, but I have a pair of 10s, and that 3 is not going to match up with anything, and that takes care of everything. So a 10 comes out with my I. Notice how I went 10 plus or minus 10i, and then I have the square root of 3 left over, and that's over 50. Any questions about that? You always still need to see if you can reduce it more. I used to tell you that this is kind of holy. After it's been reduced, you can't touch it again. So you're going to look at 10, 10, and 50. Can I take something out of all of them? Yeah, 10. So 10 divided by 10 is 1. Yet again, 1. And then I. Square root of 3 doesn't change. It's just kind of like x at that point. It's just what it is. And then 50 divided by 10 is 5. That would be your best answer because it's your most reduced format. Now, if it's multiple choice test, as we're gearing up for, if you got to this 10 plus or minus 10i squared root 3 over 50, and you look at it and you go, okay, I don't see that option there, and you have it thought to reduce, always say, okay, have I actually reduced it? Maybe I haven't went far enough, especially when you know you did everything right beforehand. Okay? Any questions about that? I'm going to say kind of one more topic. It's not going to be but a minute long kind of deal. And then we're just going to end it. I know that's a little early and we started a little bit late too. But that's a lot of information with factoring everything that I kind of want you to take time to absorb. This discriminant, if I didn't solve for the whole thing, if I didn't say, hey, I want you to do quadratic formula, if I just told you what the discriminant is, that tells me a lot of information. If I told you the discriminant's negative 300, automatically you should have told me that's going to create 2 imaginary solutions, okay? Because you know that the square root of negative is going to create an I, right? And then the plus or minus is where the 2 solutions come from, a positive I, a negative I. So if your discriminant is negative, so you plug it in and you get a negative, and your discriminant's b squared minus 4ac, then you have 2 imaginary solutions. Okay? If that's the only thing that they're asking for, that's all you have to do. So they may even tell you, hey, my discriminant is, negative 7. What do I know about it? And your answer would be, it's got 2 imaginary solutions. If it comes out to a positive number, it's just going to come out to like a normal situation with no i's. It's still going to have a plus or minus though, so it's going to be 2 real numbers or 2 real solutions. If it is neither negative or positive, it is 0. Okay, what's the square root of 0? 0, right? So when I would go like 10 plus or minus 0, well, that would just be 10. So I would only have one real solution if my discriminant it was 0. Okay. So you kind of need to know those 3 little rules. And if you don't know them, at least be able to think through them. If you don't want to commit them to memory, per se, just think through the process. Okay, so I'm going to end it there because my brain hurts and your brain probably hurts now.